Okay, so the first thing we need to do is I need to draw the influence line for the moment at C. So we've talked about this before, so what we can do is assume that this hinge at C, and that we're going to put positive moment on it. And when I do that, how would this structure behave? Is point C going to go up or down? It's going to go up. So then it will hinge, and you'll get this nice, uniform, kind of symmetric triangle for the influence line for the moment at C. So I'll just redraw it quickly. Now, what is the value?
1.
What is this value? Not 1. How would I find that value? What does that mean to be at this position on the influence line? What is at 100 feet there? The unit load. So I need to rework this problem with the unit load at point C. So I'll need to find my reactions. I don't think that's going to be too hard to do. It's right in the middle. So the reactions are 1/2 and 1/2, right? And then I want to cut it and find the internal moment at C due to that load, that 1/2 load. At 100 feet. So what is that moment? Well, if you sum the moments at the cut and make sure it's equal to 0, what do you have? Well, I have the internal moment, which is negative, and then I have positive moment created by the 1/2 times 100 feet. So what's the moment at C equal to? 50 feet. So I know this is 50. And this will have the units of feet. Everybody see that? So now I can use my influence line to solve the problem. The problem was, remember we had that 2 concentrated loads moving together. I think they were 12 feet apart. The first load was, what was it?
2 kips.
2 kips, and the rear was 5 kips. So I have 2 cases. I'll do case 1 first. So just to help you visualize this, I'll redraw the influence line for C, the moment at C. And then I will drive over my truck till the front axle, the 2 kip axle, is at the peak value. And then 12 feet back, I've got the 5 kip force. And if I extend those lines down, what are the ordinate values on my graph? Well, this one's easy. It's 50. What's this one? What's the slope of the line? Rise over run, it's what? 1/2. So every foot I move, I drop 1/2. I move 12 feet, I drop 6. So this should be 44. You guys see that? So now, the moment at C for case 1 is going to be 2 kips times 50 feet plus 5 kips times 44 feet. So what's that going to be equal to? This is 100. That's 220. That'd be 320. Yep. So that's 320, and that would be kip feet. Say case 1. So what's case 2? My truck keeps driving, and the rear axle, as it moves from right to left, will hit the high spot. So again, just to help you visualize it, I'll redraw the influence line for the moment at C. Except this time, the rear axle has moved over the maximum value, and 12 feet in front to the left is the front axle. So now I'm looking for these ordinate values. What are they? Well, the top one's easy. We know that's 50. The slope on this side is the same as the other side. So every foot I move to the left, I drop half a foot. So this is also going to be 44. So the moment at C for case 2 is going to be 2 kips times 44. That's a little bit less than before. But the next one is going to be 5 kips times 50 feet. That's larger. Let's see what it comes out to be. This is 250 plus 88, 338. So it's just slightly bigger. So the maximum moment at C for this truck would be the larger of the two, or 338 kip feet. I think that's doable. In fact, we did that in a record 7 minutes and 30 seconds. I think you can do that. Maybe with another load even thrown in. Do another case.
No problem.
Sorry?
No problem.
Did you ask me what the definition of an influence line was, Mr. Andrews? Is that what you were asking? Let me see. I might have some information on that.
You get it right. That's the test problem.
Let's see. It is November 10th, 2016. Oh, I read the wrong side. So any questions about this one? Okay. I think that brings us to the end of class for the day.